Hey everyone, and welcome. Today we are going to dive into a core concept in Java that is all about working smarter, not harder: inheritance. So, let's imagine you're an architect for a second. Instead of drawing a brand new blueprint for a car and then another completely separate one for a truck, what if you could just start with a master template for a vehicle and then specialize from there? Well, that's the power of inheritance, and we're about to break it all down. So, does this feel familiar? You're deep in your code and you suddenly realize the logic you're writing for your car class is almost identical to what you just wrote for your truck class. It's repetitive, it's inefficient, and let's be honest, it's just frustrating. You know there's got to be a better way to do this. And that brings us to what I call the redundant blueprint problem. This is way more than just a minor annoyance. When you're duplicating work like this, it leads to code that's inefficient, bloated, and trust me, becomes a total nightmare to maintain down the line. Okay, let's dive into this. On the left, we've got our car blueprint. On the right, a truck. Now, as you can see, they both share some common stuff, right? They both have wheels, and more importantly, they share the exact same steer method. We've written the same logic in two separate places. I mean, sure, it works, but it is not smart. So what's the big deal, you ask? Well, imagine you find a bug in that steering method, or you just figure out a better way to implement it. You have to go update it in the car class, and then you have to remember to make that exact same change over in the truck class. If you forget one, boom, you've just created a bug. And that is how these small oversights snowball into massive maintenance headaches. So how do we solve this mess? We do it with a master blueprint. In the world of Java, this incredibly elegant solution is called inheritance, and it's an absolutely fundamental tool for writing clean, organized, and sane code. At its core, inheritance is really just a mechanism where one class can get or acquire the properties and methods of another class. The best way to think about it is like starting with that master blueprint. You get all of its features for free, and then you get to add your own special details on top. All right, let's rebuild our example, but this time, let's do it the smart way. Instead of starting with a car and a truck separately, we're going to first design a master blueprint for a generic vehicle. This is where we'll put all the common stuff that everything with wheels shares. And now watch this. Our car and truck blueprints don't have to start from scratch. They simply inherit from that vehicle blueprint. And just like that, instantly, they both get the wheels property and the steer method, and we didn't have to write a single extra line of code to make it happen. Okay, that all sounds great in theory, right? But how does this whole master blueprint idea actually look when you're writing Java code? Let's translate this concept into the actual syntax you'll be using. It's really as simple as these 3 steps. Seriously, first, you define your master blueprint. We call this the parent class, in our case, vehicle. Second, you define your new, more specific blueprint, the child class, like our car. And third, and this is the magic part, you connect them with one simple keyword: extends. That extends keyword is everything. It's the key that makes this whole thing work. When you write class car extends vehicle, you're telling Java in no uncertain terms, hey, a car is a more specific type of vehicle. And with that one word, it automatically inherits all of vehicle's features, creating that crucial parent-child link. But here's where it gets even cooler. Inheritance isn't just about blindly copying everything. Its real power comes from the ability to take what you get and then customize it or even add to it for your own specific needs. Let's go back to our example. Imagine our master vehicle blueprint has a method called hunk, and it's just a standard, polite little beep beep. That's totally fine for a car, but a big, heavy-duty truck, yeah, that's probably going to need something a little louder. Now, what's really interesting is how we solve this problem. On the right, you can see the truck class provides its own version of the hunk method. This is called overriding. And you see that little @override tag above it? That's an annotation. It's basically a little note we leave for the compiler. It's us telling Java, hey, just so you know, I am intentionally replacing the hunk method from the parent vehicle class with this new, much, much louder version. It's a great safety check, and it makes the intent of your code crystal clear. All right, let's bring it all home. Why is this approach so much better? It's time to recap the really powerful benefits you get by using inheritance in your projects. Okay, so the crucial point is this. Inheritance is a game-changing design principle. First, you write less code, plain and simple, no more duplication. Second, you can update in one place. You fix a bug in the parent class, and poof, all the child classes are automatically fixed too. Third, it helps you build logical structures in your code. A car is a vehicle. It just makes sense. And finally, it dramatically increases reusability, letting you build brand new things on a solid, already tested foundation. So as we've seen, inheritance allows us to build these powerful logical hierarchies. But it does leave us with a pretty fascinating question, doesn't it? We've seen how a class can inherit from one master blueprint. But what happens when you need to inherit features from two different masters at the same time? Well, that's a puzzle for another time. Thanks for watching.